here, we essentially found all of that, but then we subtracted the top part. Thank you. Okay, this is a quick graphic to help you realize you can put areas together and things of that sort. Nothing that you need to write down. All right, so let's go ahead and start with question letter B. Again, this is all referencing the previous graph that we had. So now, I don't have the graph up here, so you might see me going back and forth. So definitely write the questions down. This is part B. Yes.
What was the point of the coordinate 3, 3 minus 3?
It's not there yet. Okay, we still have 5 parts to this question. So. All right, listen up. 3 to 5, 2f derivative x plus 4 dx. Right, so there's the question. Right, good job, mashallah. Alright, so let's go back a little bit so we can all kind of look at what we need, alright? So I already heard a great suggestion is why don't we split this. So go ahead and split this up into 2 integrals. The first one, you can move the 2 out. It's going to be from 3 to 5 f derivative of x dx. And the second integral is going to be simply a 4. So 3 to 5, 4 dx. Okay, you guys. Now, obviously one part of it you just literally took a quiz on. That's not the hard, which is the 4, right? You can integrate a 4 any day. However, let's talk about that first integral. How do you work with the first integral?
Doesn't it become f of 4?
And what did you use to say that? No, it's not the second.
The first is
The integral of a derivative is the first FGC. Okay, so, or just realize that, well, if you're integrating a derivative, you're just gonna go back a moment, right? So you're gonna end up with f of x then. So, go ahead and write down 2 times f of x. Right now, I'll leave it to you. I will, inshallah, do it quietly on the board. But that is the graph of f of x, okay? And you're gonna be needing things off of that graph. And this is 4x. And now it's your job to go ahead and evaluate the answer that we have. So,
Oh, that's what we gave us a book here. That,
yeah, I
that
think
coordinate.
Mason was just asking about this, right? So I think, listen, there's the answer to your question, sister. Alright.
Yeah, so isn't it just 3 minus root 5, not 3 minus 3 times root 5?
As I get 2 minus, so 2 plus 2 root 5 is the final answer. Yes, Alex.
Did the 3 minus root 5 become negative from the minus sign?
Yeah, let me put a parenthesis for you. Good point. So that's a parenthesis, right? So everything swaps over. Then you multiply that 2 in the beginning of the bracket, so it becomes 6 minus 2 root 5 with a negative. So that's a negative 6 is a positive now. And then, do you guys understand where I got the 8 from?
Yeah.
Okay.
Well, okay, so that's
Alright, so that was part B. I really want to finish this today. I want to make a third day of the same question. Okay, it's going to start getting a little bit more serious now. Alright, so go ahead and write down g of x is equal to the integration from negative 2 to x f of t dt. Okay, our job today is to find the critical points and the inflection points of g, and then to also determine whether these critical points that we're going to have are maximums, minimums, or neither, and then we're going to justify it, okay? That might actually take us into the end of the class. So again, I need the graph, so I'm going to step back a little bit so that we can take a look at the graph here. And before you start reading the graph, let's go ahead and work with this. So first tell me, if you want to tell about maximums, minimums, anything like that, what do you first need to do with this equation? Take its derivative, right? You have to take a derivative. And then if you want to talk about inflection points, what would you need to do with that? You would have a second derivative. So go ahead, take a minute and write down the two important facts. This again is the accumulation function. This is the equation for the slope of g, right? So now we can tell about increasing, decreasing, maximums, minimums, all of that other good stuff. And finally, the third conclusion that we reach is that means the second derivative of g must equal the first derivative of f. Alright? So again, that uses the second FTC to make this conclusion. That just is the way that it is. Okay? Alright, now go ahead, make 2 bars on top of that. Again, to save myself some time because I only have 9 minutes, I will make the bars on the graph itself. Okay, so make 2 bars on the graph. Go ahead and read the g derivative and the g double derivative. Remember the discussion yesterday? That graph, which is called the graph of f, is now the graph of g derivative. Okay, so you're reading a derivative graph of g, and the whole question is about g, it's not about f. G derivative is equal to f. Always make those connections. Don't just label it as g derivative, and make sure you label the second bar as g double derivative is equal to f single derivative. Alright, when you're done, look up, and first you gotta make sure everybody's good with reading the graph, okay? Please, some of you messed this up last test, so if you messed that up, you're gonna mess this up. So you need to speak up if you don't understand this. Okay, so let's go ahead and start writing out some conclusions, okay? I taught it to you yesterday, so you just need to go ahead and follow along. I'll quietly do it on the board here, and then inshallah we'll talk in a couple of minutes, alright? Remember the first question was about critical points. Then the second question was about maximums, minimums, and neithers, and the third question was about inflection points. You always have to justify what it is you're about to say. Yes?
Well, you see that blue that's like on 5, is that also not a point for
It is a critical point. That's a great remark, but the problem is, it's not a problem, but look, it's the end of it, so we don't care about it. It's the end. Sure. Okay, so take a look at these four statements. Again, it takes me forever to write these, but man, I'll keep writing them until even if there's one person who still doesn't understand it. And there definitely there's 3-4 people in this room who don't get the statement. And some of them, they're writing more than they have to, okay? Please don't do that either. This last one over here, it's very common to just kind of say, oh, because g double derivative is equal to 0. Look at it very carefully. You guys take a look at 2. What do you notice about the derivative at 2?
Neither.
What is the derivative at 2? It's a, well, either one, right? It's a sharp turn. So can you actually say that the derivative is 0 there?
No.
It's not. So be careful of saying that something is 0, alright? You just need to tell me that it switches signs, alright? Don't be extra. Don't be extra. Just say what you need to say, and this is what we're looking for. You can, if you want, you can say that g derivative is equal to f goes from increasing to decreasing or decreasing to increasing. You can say that, but you're going to have to add more to your lines. It's just easier to mention switches signs there when it comes to inflection points, okay? Any questions about letter C that you don't understand? Well, it looks like we're going to have to finish this tomorrow, okay? So great job. Keep